Okay, good day class. Alright, so today we will start the first conics ellipse. 5.1.2 ellipse. Okay, so let's see what is the definition of a unit ellipse. Okay, so it's given that an ellipse is defined as the locus of all the points on the plane such that for each point on the ellipse, the sum of each distance from two fixed points is a constant. All right, so this is the definition of an ellipse. It's also a locus. It's a locus of a moving point such that the sum of the moving point distance from two fixed points is a constant. It's always the same. All right. For further information, you can refer to your textbook page 222. All right. So I will explain here. Okay. So the question says, let's say you have a straight line. All right. And on this straight line, you have two fixed points. Let's name it F1 and F2. These 2 points fixed. Okay, it's there. All right. So let's say if now P is here. Okay, let's say P1 lah. Then its distance from these two fixed points, here and here. All right, will be a constant. Means P1 F1. Okay, plus P1 F2 will be equals to A. All right. Then let's say now P move here. Let's say P move here already. Let's say P2. All right. So same. Even though P already moved here, so its distance from these two fixed points, the sum of its distance from these two fixed points should be also always same as the constant A. So means that P2 F1 plus P2 F2, the sum of these two distance also must be the same. It's a constant. All right. So if let's say P is here, let's say for example P is here. So its distance, let's name this one P3. All right. So its distance from these two fixed points means P3 F1 plus P3 F2. P3 F1, P3 F2 also will be equals to A. All right. So no matter where P moves, it must satisfy this condition. All right. So when you join all these moving points, then it will form a locus. It will form the locus of the moving point P, which is an ellipse. All right. So P will move along here such that it can satisfy this condition. Means wherever is it, its distance from these two, the sum of its distance from these two fixed points must be always the same. All right. So when we join all these moving points, then you will see an ellipse. Okay. Okay. So let's go back to the notes. Number 2. So the two fixed points are called foci. These 2 points. If one point focus lah, all right, plural become foci. All right. So these two fixed points we call it foci, and the line that passing through the foci will call the major axis. This line. This line that passing through this foci, then we call this major axis. All right. Means the longer segment lah. And the midpoint of the foci will be the center of the ellipse. All right. So this is focus F1, focus F2. So the midpoint, all right, between F1 and F2 will be the center of the ellipse. All right. Then the straight line that passing through the center of the ellipse and perpendicular to the major axis, we call it minor axis, the shorter segment. Okay, means this one. A line that passing through the center perpendicular to the major axis. So like this. From here to here. This line, we call it minor. Right here. We call it minor axis, which is the shorter one. The longer one is the major axis. The shorter one, we call it minor axis. All right. So from here, you know that in an ellipse, we will emphasize on center, foci, major axis, minor axis. All right, so let's see, this is a complete one. Here is an example of the ellipse. So the ellipse is symmetrical about the major and minor axis. This is the minor axis, this is the major axis. It's symmetrical. And P1F1 plus P2F2 equals A, P2F1, P2F2 also A. This is the definition for the ellipse. The sum of each distance from two fixed points are always the same. Okay, and the chords of the ellipse passing through the foci and perpendicular to the major axis, we call it latus rectum. This line. This is the focus, right? This is the focus. So line that passing through focus and perpendicular to the major axis means this one. The chord, so touching these two sides. This line, we call it latus rectum. Here also another latus rectum. Alright, so you see here, okay, major axis, the long one major axis, the short one, the long one major axis, the short one minor axis, focus, alright, and then center, latus rectum, okay. Okay, and actually there is two more that we call vertex here. The two endpoint on the major axis. Alright, vertex. The vertex of the ellipse. Okay, so this is a concept for ellipse. Alright, so when we talk about ellipse, as I said, we emphasize on the center, right? So we will separate it into two types. So the first part is 5, 1, 2, 1, and ellipse with the center at the origin. The center is the origin with coordinate 0, 0. So we will see how the equation looks like. Then later we will see another one with ellipse with the center, not the origin. Okay, so we will look at the ellipse with the center at the origin first. Okay, so to find the equation of an ellipse with the center at the origin, so this is y-axis, this is x-axis, so this is the center, is the origin. All right, so how to form the equation? Okay, so let's see the step. Number 1. All right, so let's say P is a moving point, so we coordinate xy lah, not fixed it's moving, so xy. Okay, be any point on the ellipse. So assume that the foci are F1 and F2. Here. All right, since the center is the origin, so the x-axis will be the major axis, right? So F1 and F2 lies on x-axis lah. Okay, since they are lies on x-axis, so the coordinate for it will be negative C0 and C0. Because it's the distance from origin 0 and on the x-axis, the y coordinate is 0, right? So this is negative C0, this is positive C0. Okay, the coordinates. And the constant value is 2a. Just now we say it must be always a constant, right? So a constant, I can write it as a, I can write it as 2a. 2a also a constant, right? Okay, so in here, to get the equation of the ellipse, we will assume that the constant is 2a lah. Because it's just that make our calculation easier. That's it. All right. Then we start with the definition of the ellipse. Its distance from the focus. So Pf1 plus Pf2, the sum of the distance from the two fixed points must be equal to a constant 2a. Okay. So we start from this definition and get the equation. All right. So I show you the detailed step here. Okay, so we start with this. Pf1 plus Pf2 equals 2a. P is a roaming point with coordinate xy. So F1, the coordinate is negative C0. F2 is coordinate C0. One negative, one positive. So start with the definition. Okay, use the formula for distance. So Pf1 is x, F1, this one. So x minus x. So x minus negative c, x plus c square. Y minus 0 square root. Plus, this is the formula for Pf2, Pf2, and equals to 2a, right? So next step is I move this one to the right hand side, become minus. Okay, why I do this step? Because to eliminate the square root, I need to squaring both sides, right? So if I squaring both sides directly from here, so I will still have something in square root. Okay, so if I move this one to this side, then our calculation will be easier. That's it. Easier for us to calculate. So remember this step. we shift this one to the right hand side first. Now, the next step is we squaring both sides. Then only we do squaring both sides. So left hand side, squaring the square root, so no more. Alright, so right hand side, so we expand the quadratic lah. So first term square, so 4a square. Second term square, so eliminate the square root, become like this. Then 2 multiply this and this, so minus 2 multiply 2a, 4a lah, and this one lah. Okay, then next step is we expand all the quadratic. So x square plus c square plus 2cx plus, okay, next step is, you see, y square can be simplified. Y square minus y square, no more. Alright, so 4a square, this one also expand x square, c square minus 2cx. This one as usual. Okay, so next step is, because this is minus, so I shift this one to the left hand side so that it become positive. Later we have to do another time of squaring both sides. Alright, so another one that cancels out is x square, x square minus x square, no more. Okay, 4a square remain. So 2cx shift here minus 2cx, so minus 4cx. Alright, so we simplify and rearrange in this way. Then I see 4, 4, 4. Right, so the next step is I divide the whole thing, multiply lah. I multiply the whole thing by 1 over 4a. Multiply this one by 1 over 4a. So left hand side multiply 1 over 4a, cancel, left this. This one multiply 1 over 4a, left a lah, because it's SUM. So cancel with 1a, so a lah. This one multiply with 1 over 4a, 4 and 4 simplify, so cx over a. We simplify in this one first, then only continue to expand, easier again. Alright, so again the next step we squaring both sides to eliminate the square root. Okay, left hand side squaring both sides, squaring, so eliminate the square root. So I expand x square plus c square minus 2cx plus y square. This one also expand, first term a square, second term square, then 2 multiply a multiply cx over a. So a and a simplified, so minus 2cx. Just expand. Now we are going to rearrange it. Alright, so let's see. Okay, the next step is I multiply the whole equation by 1 over a square. By 1 over a square. Hold on, let me see. Not yet. Not yet. So until after expand until this step. Okay, I rearrange first, right? I rearrange first. Not yet. I rearrange first. So I see x square here, I see x square here. Okay, so I shift this term to the left hand side. So x square, this one shift here, minus c square over a square x square. Alright, plus y square. Okay, and 2cx simplified, yes. Minus 2cx, no more. Simplified. Okay, then this c square shift here. Yes, correct. This one x square and x square. So I shift this one to this side so that later I can factorize. Y square remain here. Okay, c square shift here. A square remain. This one and this one no more. Okay, then next step, yes. X square and x square. So I factorize it. Become 1 minus c square over a square, x square plus y square, okay, equals to a square minus c square. Okay, this one I combine to become one fraction. So it's a square is 1. No? So it becomes a square minus c square over a square. Alright, so in this way. Okay, so after that, after we have combined as a single fraction, then I multiply the whole equation by 1 over a square minus c square, this one. Okay, 1 over this. Okay, so the first term multiplied with this one, so cancel. So become x square over a square only. This one, denominator is 1. So multiply with this, so become y square over a square minus c square. So this is one whole thing. So when multiply with this one, become 1. Yes, this is what we want. So we don't write a square minus c square here lah. We make it, how to say that? We make it more tidy, look nicer. Therefore, we write it in this form. So x squared over a squared plus y squared over b squared equals 1. What is b? What is b squared? B squared is actually equal to a squared minus c squared. Huh? We don't write in this form. We write in this way. So look nicer. Okay? So this is the equation of ellipse, and we call it standard form. Okay? We call it standard form. So the standard form of the equation of an ellipse with the center is at origin. This center at origin will be x squared over a squared plus y squared over b squared equals 1. Where b squared is a squared minus c squared. So remember, the right hand side must be 1. Okay? Cannot be other numbers. So when you see one equation in this way, then you know this is an ellipse. Okay? What is A? What is A? A is the half of the constant distance. Right? A is half of the constant distance. And what is C? C is the foci. See that? So from if you are given all this information, then you should be able to find your A and B. Alright, this is what you get, how you get your A and B. But actually, in the diagram, let me see. So I explain it in a more detailed way, where one equation is expressed in standard form. When the equation of the ellipse is expressed in standard form. Alright? Okay. Alright, can see? Alright, so you see, this is the equation, it's the standard form of the equation of ellipse with center origin. X squared over a squared plus y squared over b squared equals 1. So this is the graph. Okay, y-axis, x-axis, origin is the center. Okay, so the foci will be here, F1, F2. Alright, so center, 0, 0. So what is this A means? Okay, so you see, when y equals 0, so this thing 0 lah. So a square move here. So x square equals a square. So x equals plus minus a. So this x equals plus minus a is actually the vertex on the major axis here. Yes, this is your a. So this is negative a. This is positive a. Alright, and this is the vertex. So the coordinate for the vertex will be negative a, 0, because on x-axis so the coordinate for this one will be a, 0. So these are the vertices of the ellipse. Alright, then you check when x equals 0. When x equals 0, this one 0, right? So b square shift here. So you have y square equals b square. So y equals plus minus b. This is also, actually we can call it vertex also. But normally when we talk about vertex, we are talking about the point, the end point of the ellipse on the major axis. Alright, so where is the plus minus b? Here. This is b. This is minus b. Alright? And of course, a cannot be equals to b lah. Alright, so this distance and this distance cannot be the same. Then only it becomes ellipse. If a and b are the same, let's say a and b are the same, so what do you think it become? What is the shape if a and b are the same? Yes, if a and b are the same, it become a circle. Yes, it become a circle, right? That's why, remember at the beginning of the chapter, we say that circle is actually a special case of ellipse. This is their relation. See or not? Okay. So remember the standard form of the equation of ellipse with the center at the origin. And how you can get all this info from the equation. Okay, so when you see this is only x and y, so definitely center origin, because it's like x minus 0, y minus 0 ma. Okay, and this a and b will be the vertex. Vertices. Alright? So when you get this thing, you can find your focus also, right? Because focus is c squared is equals, b squared is equals to a squared minus c squared, right? So from here, you get your focus. Because I have, from the equation, I have a and b. So when I rearrange this one, after I calculate, so I know where is my focus. C is the coordinate for focus, right? Okay, So this is how useful when we express one equation in standard form. Okay? All right. Okay, so number 3. So the equation of an ellipse with the center at the origin is this one. We have already said. Where b square is actually equals to a square minus c square. A is the half of the constant and c is the foci. Alright, and the x-intercept are plus minus a, y-intercept will be plus minus b as I explained just now. Okay, so now the next table show you that actually we have 2 shapes of ellipse. Okay, in Form 6 syllabus. In Form 6 syllabus, we are going to learn these 2 shape of modulus. Ellipse. 2 shape of ellipse. Okay, one is this one, like horizontal. Another one is vertical. Alright? So this one just now we have discussed. Alright, we have explained. So when it is a horizontal, horizontal ellipse, so the major axis, remember, the major axis will be the horizontal line. Okay, this is for center origin. So it means that how I know, then you will ask, then teacher, how I know this is horizontal or vertical? Very simple. You look at your A and B. Okay, if A bigger than B, A is the constant below X. So if A bigger than B means X axis is the major axis. So it's horizontal. See? So if B bigger than A, so means B bigger than A. This number bigger than this. So B is under Y. So from here you remember, if B bigger, then the y-axis is the major axis. Longer, right? Longer. See? It's a major axis. So it's a vertical shape of ellipse. Okay? Remember this. Alright, so let's see one by one. So if A bigger than B, again, it's a horizontal ellipse. The equation will be like this. Okay? So the major axis is the x-axis. Okay, and the foci from here, just now we already say, right, b square is equals to a square minus c square. So when you rearrange, c square is a square minus b square. We get ab from here. Okay, so you will find 2 values of c, negative and positive. So this is your foci here. See? Then vertices of ellipse, these 2 lah. Vertices of ellipse, these 2. From the A. And lattice rectum. See, remember lattice rectum? The length. This is the length of the lattice rectum. So remember, lattice rectum is a vertical line. It's a line passes through the focus and perpendicular to the major axis. Means this one. The chord, you see, touch the side, touch the circumference of the ellipse. This is lattice rectum, and the length of this line will be 2b squared over A. Okay, the next step is when B bigger than A. So as I said, B is under Y. So Y-axis is the major axis. So the major axis is the Y-axis. We still write in the same form. Okay, then same. To find the C square. Just now C square is A square minus B square, right? Because A bigger Okay, but now B bigger, right? Since B is bigger, so your C square is B square minus A square Okay, you cannot use A square minus B square anymore. Then you get negative what? C square cannot be negative, right? Okay, so it becomes B square minus A square. Then again, you get the foci. So now your foci is here already. Because major axis is y-axis. So foci lies on the major axis. So your foci is here. Alright? So the vertices will be here. Everything. Foci, vertices, center, all lies on y-axis if it is vertical. If it is horizontal, you see all the foci, center, and the vertex all lies on x-axis. All these points, 1, 2, 3, 4, 5. All these 5 points lies on the major axis. Remember. Therefore, the vertices of the ellipse will be 0, negative b, 0b because lies on y-axis x coordinate 0 Okay. And the lattice rectum. What is the lattice rectum for this one? So remember, the definition for lattice rectum is a line passing through the focus. So this is the focus. Passing through here and perpendicular to the major axis. This is the major axis, so perpendicular. Now your lattice rectum is like this. From here to here. Okay, or this one, from here to here. Perpendicular. This one also perpendicular. Okay, so the length for this lattice rectum will be 2a squared over b. If like this, 2b squared over a. If like this, 2a squared over b. Okay, so this is the shape of the ellipse when for horizontal one and the vertical one. Okay, so the next step is how we are going to sketch an ellipse. Yeah, in exam, actually they would like to ask you to sketch. All right, so to sketch the ellipse, first we express the equation in standard form. Because when it is in standard form, we can get all the information that we want to sketch it. But remember, standard form, right hand side must be 1. And center here is plus. Okay? Okay. Then identify the center. So when you see x squared and y squared only means center is original, 0, 0. Okay? Then identify the major axis. So see which one is bigger. And the minor axis. Then C, make sure the shape of the curve is correct. Correct means either is vertically or horizontally. Then D, label all the points where the curve cuts the major and minor axis. Then means these 4 points. Label all these 4 points. Then E, draw a smooth curve through the points. Alright? Okay. Then now we will see how we are going to sketch an ellipse. So look at example 5.1.2.1. Okay, question 1. Sketch the graph of these two, A and B. Okay, I will discuss A. Alright, so the equation, the ellipse for A is x squared over 9 plus y squared over 4 equals 1. Alright, so let's look at here. Alright, you can see, Okay. So this is the standard form of the equation of ellipse. Alright, so we rearrange this one in A square. So 9 is 3 square, 4 is 2 square. Okay, so A bigger than B, right? 3 bigger than 2. So A bigger than B, so I know that the shape is horizontal. Okay, the major axis is x-axis. Alright, center, origin. So x-intercept will be plus minus 3 because A is 3 ma. Y-intercept plus minus 2 because B is 2, so plus minus 2. Alright, then to calculate the foci, so we know that this B square B square is actually A square minus C square. So when we rearrange it, so we can calculate. So A square is 9 right here. B square is 4. So C square equals 5. So C is plus minus square root 5. Alright. So after you have all this information, then now you can sketch. Alright. So center is the origin. Okay. X-intercept plus minus 3. So means the vector the vertices. Okay. Y-intercept is plus minus 2 here. Okay. Foci is square root 5. So square root 5 is 2 point something somewhere here negative square root 5 and positive square root 5. This is the focus F1 and F2. F1 and F2. These two we just mark only and label. The ellipse won't pass through this one. Okay, now we can join all these 4 points. Okay, and become a ellipse. So I encourage you to draw like this. Draw a curve first here. Draw a curve here also. Draw a less curve here because this is okay, then you join it. Okay, then you join them. So from here, join here, from here, come here, then from here, join here, join them. Yes. This one not nice. Okay, this one like this better. Okay, so you get the ellipse. See? Not difficult, right? Okay, so I want you to do B as homework. So you see, B, you are given this. You see the right hand side? 2. Okay, so I explain to you. You can do it as homework. So because this is 2, as I say, the standard form here must be 1. So what to do? You multiply the whole equation by half. So this one multiply half becomes 6. This one multiply half becomes 10. So this one multiply half becomes 1. And then now only this is the standard form. Okay, then a square will be square root 6 square. 6 means square root 6 square. So this is your a, this is your b. Okay, then which one bigger? Y bigger, right? Yes, you know the shape is a vertical one. So you go back and try this one. Follow this step. Just follow the same step. All right? You do this as homework. Okay, so next one will be checkpoint 5.2. Okay, question 1. Alright, so checkpoint 5.2. So please open your textbook. Page 226. Alright, open your textbook, page 226. Yeah, checkpoint 5.2. So it's here. Okay. So you see, you're asking, question 1, you're asking to sketch each of the following ellipse and find all these 4 in 4. Focus, foci, vertices, length of the lattice rectum, length of the major and minor axis. So after you sketch, they want all these 4 in 4. Alright, so I'm going to discuss 1D. I'm going to discuss 1D, and your homework will be B and E. Your homework will be 1B and 1E. Alright, so I'm going to discuss 1D here now. So 1D, you are given the equation of ellipse in this form. So this is actually the general form. We haven't discussed this one later. Alright, so 9x squared plus y squared equals 9. Okay, here. Alright, can see. Okay, can see that? Alright, so I put it here, it's easier. Okay, so this one. So first step, we express it in standard form. So because I see standard form, this one must be 1. So to make it 1, I multiply the whole equation by 1 over 9. So this one multiply 1 over 9 become this. This one multiply 1 over 9, and this one multiply 1 over 9. So you see it is in standard form. Then maybe you say, why there is nothing under x squared? God. So if nothing labeled here means that under x squared is 1 square, okay. So now we express it in standard form already. So first step, center. This is x minus 0, y minus 0, so center is origin 0, 0. A is smaller than B. B bigger. B bigger. So I know that it's vertical one. It's a vertical shape. Alright. Then you know the xy intercept. X intercept is 1 plus minus 1. Y intercept is plus minus 3. Okay. And the foci. This one later lah. Okay. So x intercept is plus minus 1 here and here. Okay, y-intercept is plus minus 3. Here and here. Center is the origin. As long as you get these 4 points, now you can sketch already. So as I said, we always make a curve. Here. A little bit curve. Then we join them. Okay. Right, so you see, now you get the vertical ellipse. Alright, then after that, the question want 4 information, right? First one, they want the coordinate for the foci. So we know that c squared is equals to b squared minus a squared. Remember, because b bigger, so b squared minus a squared. So 9 minus 1, so 8. C squared equals 8, so c is plus minus 2 square root 2. 8 is 4 times 2, so square root 4 is 2, so 2 square root 2. So the foci, the coordinate of the foci will be 0, 2 square root 2, and 0, 2, negative square root 2. Because it is on y-axis. So please label x and y. On y-axis, x coordinate are 0. Alright, then the question 1, the vertices. So these two. When we talk about vertices, we are talking about the endpoints that lies on the major axis. Also, it's 0, 3 and 0, negative 3. Okay, number 3, they want the length of the lattice rectum. But before that, we need the we need the foci lah, because the rectus rectum pass by the foci. So focus is 2 square root 2. So 2 square root 2, it will be roughly 3.6, 2.8. Square root 2 is 1.4 something ma. So it will be 2.8, not check 3. So this is the foci. The foci is here and here. Not check 3 lah. Very close to 3. Okay, so the rectus rectum is this one. This red color line, perpendicular. Here also can. It should be the same because it's symmetrical ma. Okay, but we use formula. So see, if vertical, then the length of the rectus rectum will be 2a squared over b. We use the formula. So 2a squared over b. So 2a squared is this one, b is this one. So it's 2/3. The length of this line, the length is 2/3. Alright, so the major axis, the length of the major axis from these two vertices. So this is 3, this is 3. So the length of the major axis 6. The length is 6. So minor axis is here. So this is -1, this is 1. So minor axis, the length is 2 units. It's the length, so units lah. Okay? Alright, so you homework will be question 1, you do B and E. So follow exactly this step. Answer everything that we want. Okay? Alright. Then next, just now we are looking at the ellipse with center at the origin. When center at the origin, then the equation, the standard form will be in this way. Okay, now we are going to see 5.1.22, this one. Can see it. Okay, 5.1.22, an ellipse with the center HK. HK means it's not origin. Okay, never mind. Maybe I stop here first. After you finish your video, okay, after you finish this video for the ellipse with the center at the origin, okay, please complete your homework. 3 questions only. 1B in the notes, and in the textbook, question 1B and E. You complete this one. Then I will share you another video for ellipse with the center HK. Alright? Okay, thank you class.